I'm here a little bit to talk about a new book called Rebooting AI, Building Artificial Intelligence We Can Trust. This is the first time I've ever talked publicly about the book. As she mentioned, it's coming out in September. It's a bit of a sneak preview. At the next event that this organization runs, I will do the European premiere of this book. As already mentioned, a lot of what I've been thinking about lately is deep learning. And really, I've been thinking about deep learning for over 20 years because my graduate work with Steven Pinker here from Montreal was about children, how they learn language and neural networks. Neural networks that were predecessor to the deep learning that we heard about at this conference and we read about all the time. And I'm going to say a lot of things that are critical about deep learning, but I want to start by saying that some positive things. I think deep learning really is a revolution in artificial intelligence. I think that it's fantastic for certain things, like recognizing objects, recognizing faces, understanding, well, not understanding speech, but identifying the words in speech, recognizing patterns in board games, and so forth. So deep learning is really a wonderful tool. But my argument is essentially going to be that it's just one tool among many, that we need a lot of them. So all of these successes are examples of one particular kind of thing we need to do in artificial intelligence, which you might call perceptual classification, recognizing particular kinds of patterns. That's important, but I want to suggest that there's more to what you might call artificial general intelligence, or more to intelligence that we can actually trust, artificial intelligence that we can trust with driving our cars or taking care of our homes, and so forth. So last year, I wrote an article that enraged, I think, a lot of the field, but a lot of the field has maybe come to see the wisdom of a year later. So the article was called Deep Learning, a Critical Appraisal. It's available free on arXiv. I hope many of you will take a look at it. The short version is this summary that Wired did of the article. It said, greedy, brittle, opaque, and shallow, the downsides to deep learning. So the article was picked up widely in the media because it was challenging to this orthodoxy that deep learning is going to get us to artificial general intelligence. I'm not going to go through all of the reasons today, but I'll give you at least a little bit of the flavor. Part of the reason I'm telling you this is I don't want you to believe all the hype that's around deep learning. I want you to understand that we're actually pretty far from general intelligence. So here's an example of the kind of hype that led me to write the critique. Andrew Ng, who's one of the leaders in developing deep learning, wrote in Harvard Business Review, if a typical person could do a mental task with less than 1 second of thought, we can probably automate it using AI either now or in the near future. So that sounds like we've got close to general intelligence. It's just around the corner. Anything you can do in a second, which is most of what you do, will get a machine to do it. And I've been arguing that this is a more serious version of, a more realistic version of what Andrew Ng said. So the reality is it depends. Can I get a machine to do that in a second? Well, it depends on what it is. It depends on what kind of data I have available. It depends on how fluid the situation is in the world that I'm trying to model. Here's my paraphrase that I think is more realistic. If a typical person can do a mental task with less than 1 second of thought, and we can gather an enormous amount of directly relevant data, we have a fighting chance, so long as the test data aren't too terribly different from the training data and the domain doesn't change too much over time. So you can think about Go. Go is exactly the sort of thing that deep learning is good at, or deep reinforcement learning that we heard a bunch about yesterday in Mark Belmaire's talk. That's a situation where you can get as much data as you like by having the computer play itself. You have something that's stable over time, right? Go has not, the rules of Go haven't changed in 2,000 years. That's very different from ordinary living where things can change every moment. You can never really get enough data and so forth. So if your mission is to distinguish between Tiger Woods and a golf ball, you can get a lot of labeled examples. The world is stable. Tiger Woods is never going to look like a golf ball. A golf ball is never going to look like Tiger Woods. You get supervised data. You feed it into a deep learning network. And you have big data yield a statistical approximation, and you're good to go. And it was excitement about this that led to all kinds of headlines like, deep learning will soon give us super smart robots. Well, that was May 2015. It's 4 years later. You're not going to find any super smart robots anywhere around. So a lot of these headlines, I think, overpromised. And on the left, I have a picture of, we saw something very similar yesterday, of playing Breakout with DeepMind's DQN algorithm, deep reinforcement learning algorithm. And it looks great. It plays better than human beings. But as it says on the right, this is work by Vicarious, and the movie will roll in a second, I hope. Okay, I couldn't get the movie to roll. Can we go back one slide? maybe not. What we find is if you change things even by a few pixels, it doesn't work anymore. So in the video I'm having trouble showing, if you raise the paddle by 3 pixels, the system completely falls apart. So it's memorized what to do in a particular screen on breakout. It hasn't learned, unlike what this video says, really what a wall is or anything like that, or what a paddle is. So the solutions are very shallow. I'll give you some more examples. You can train a neural network on all of the pictures on the right and a lot more, tens of thousands of pictures of elephants. Doesn't mean that they're going to recognize the one on the left. This isn't published in the literature. I just came up with this one. But you show a silhouetted elephant to a deep learning network, and it says person. Right? There's something absolutely bizarre from a human perspective about coming to that conclusion. There are millions of examples like this. One of my favorite papers from last year showed that if you had a school bus on its side on a snowy road, a deep learning system would say it's a snowplow, right? I don't hear anybody giggling and I don't hear anybody panicking, but if this is the algorithm that drives your driverless car, you should be really genuinely worried. Maybe you don't need to be as worried about a baseball being mistaken as an espresso, but again, if you're trusting these systems, you should be really worried. Here's another example. Deep learning has no trouble recognizing a banana at the top, but you put this weird psychedelic sticker next to it and it suddenly thinks the banana is a toaster. And that's just the beginning of the problem. So I was looking at the sweet spot of deep learning, which is identifying objects. But what if you have to understand the scene? So deep learning might tell you that this is a dog and a barbell, but there's no way that deep learning is going to report as its output looking at this image, wow, I can't believe how ripped that dog is that can manage to lift that barbell. You can figure that out in a second that this is bizarre. There's no AI anywhere near us can do that. Here's another example. I just found this on Twitter. Somebody paints a picture and their son, I think, posts it on Reddit, and someone else paints a picture of that. I painted somebody's mom. Someone else says, took a while, not perfect, but I painted the guy who painted the other guy's mom. We call this recursion. And now imagine that I try to have a deep learning system capture this or tell me why it's interesting. I painted the girl who painted the guy who painted the other guy's mom who painted an egret. If you're human, you should recognize this as an example of recursion. You might not know the term. Deep learning systems can't do that. They don't, we say that they're working on vision, that they don't have comprehension about the scenes that they're looking at. Here's an example of a deep learning system that reminds me of Oliver Sacks and the actual output from it. So this is a parking sign filled with stickers, and the deep learning system came back with a refrigerator filled with lots of food and drinks. This is where we actually are. So I keep thinking about Winston Churchill and want to paraphrase him. He says, if he were talking about AI today, I think he'd say deep learning is the lamest form of AI we've got, except for all the others. It works a bit. It works better than classical AI. It doesn't mean that we've reached artificial general intelligence. I want to give you a worked example from my new book that's borrowed from a story by Laura Ingalls Wilder, who wrote the Little House on the Prairie books. Probably some of you know it. How many people know Laura Ingalls Wilder, just out of curiosity? Because we're about to do the interactive part of the show. So you didn't all see Little House on the Prairie and repeats when you were kids? Okay, so here's the story. And I'm going to go through a story in a little more detail than I usually do in a short talk, because I want people to understand that there's a mismatch between what deep learning is good at and what we humans do just every day. So here's a children's story, right? This is written for 9-year-olds, and it features a 9-year-old. The 9-year-old's name is Almanzo. He finds a wallet. They called it a pocketbook back when this book was written. It's full of money on the street, and the father of the little boy guesses who this wallet might belong to, namely a guy named Mr. Thompson. So they track down Mr. Thompson. Now I'm actually going to read you the story, and I'm going to do a little reading comprehension on you. I'm going to test whether you've understood the story. So Almanzo turns to Mr. Thompson and says, "Did you lose a pocketbook?" Mr. Thompson jumped. He slapped a hand to his pocket and fairly shouted, "Yes, I have. $1,500 in it, too. What about it? What do you know about it? Is this it?" So Almanzo asks. Yes, that's it, Mr. Thompson said, snatching the pocketbook. He opened it and hurriedly counted the money. He counted all the bills over twice. Then he breathed a long sigh of relief and said, "Well, this stern boy didn't steal any of it." So now, comprehension questions. Why did Mr. Thompson slap his pocket with his hand? Can anybody tell me in the front row I can see? He wants to know whether the wallet's there. Did he know before the little boy spoke that he had lost his wallet? No, he didn't know that the wallet was there. He's surprised, right? So we go on with questions like that. What is he talking about when he says, is this it? Who almost lost the money? And so forth. Was all the money still in the wallet? And you can infer that it was. In order to answer questions like this, we have to construct chains of inference. So why did he slap his pocket with his hand? And we were starting to get from the second row here an answer. So a longer answer would be something like he was asked about his wallet, he cared about his wallet, he knew that he tends to keep his wallet in his pocket. This is all what we call common sense knowledge. He knows that he can sense the presence of his wallet by using his hand to evaluate whether the pocket is holding an object of a certain sort. When the wallet is not where it expects to be, he concludes that the wallet is lost. You did something like that, right? The thing is, what we have now, what passes for natural language understanding, what it really does is predicts the next word in a sentence. It doesn't do any of this, which means that functionally, deep learning systems and all of our AI systems are illiterate. Right? Everybody's excited about AI, but the reality is AI can't read as well as a 9-year-old child. Why does this matter? It matters because AI is never going to get to its real promise. We're never going to get AI to do the things that it could be doing for the world unless we change direction and start solving some of these problems. So what we want, what I want, I should say, is AI to be able to do scientific discovery, to invent new ideas and to help us with problems that are too complicated for human mind to understand. So you think about all of the molecules that are involved in biology, for example. There are hundreds of thousands of different molecules. It's too much. And so we've made relatively little progress on oncology and even less progress on Alzheimer's and so forth. We want computers to be able to help with this, but they've got to be able to read. And the reality is, if you give even an 8th grade science exam to contemporary computers, they fail it. So this is from something that the Allen Brain Institute did about 3 years ago, but I don't think there's been any real progress. We don't have, even though people are really excited about AI, we don't have systems that even can do basic science, and that's disappointing. There's a great quote from Jeff Hammerbacher. He says, "I saw the best minds of my generation working on how to make people click on advertising." A lot of AI is really about optimizing advertising and things like that. I want it to be about optimizing science. So that means we're going to need some change. Here's another example. There was some discussion of these kinds of things yesterday. If you do a Google image search for professor, about 80 or 90% of the answers or pictures you get back are white males. The actual data, on, at least in the United States, is only 41% of professors are white males. You can go home and you can do a Google search for mother and look at the race distribution. And you will find that they're almost all white, right? Mothers around the world are of many different races, but Google image is going to give you that mother is a white woman. So we also have these problems where even like basic, I don't know if analysis is the right word, but getting basic things out of systems is not very good because they blindly, and this is the key point, they blindly dredge whatever data is in front of them. So why do you get a lot of pictures of white males for professors? Because there have been like a lot of movies that have white male professors, and Google doesn't know the difference between representative data and unrepresentative data, or biased data, unbiased data. The systems aren't clever enough to think about things like that. So what do we do about that? Well, the machine learning approach, which was perfectly captured in this cartoon by XKCD, is you just get more data and you just keep stirring the pot until you get there, right? So one person says to the other, this is your machine learning system? Yep, you pour the data into this big pile of linear algebra, then collect the answers on the other side. What if the answers are wrong? Well, you just stir the pile until they start looking right. This is basically what's happening in machine learning right now. And sometimes people make a bigger pile of data and they hope that will solve the problem. I want to suggest we ought to look in a different direction. And what Ernie Davis, my collaborator, and I are suggesting is that we should look for clues from the human mind. So I'm going to give you a few of those clues. The first is I think we should stop looking for silver bullets. People are looking for the one algorithm that's going to rule them all. They've been doing this since the days of behaviorism, which is a psychological theory that disappeared in the 1950s, but that was completely dominant in the 30s and 40s. We have to be realistic. What deep learning is doing is perception. But intelligence is about many things. It's about common sense. It's about planning, analogy, language, reasoning. All of these kinds of things. And so what I said, and nobody seems to have noticed in this article that provoked everybody, is despite all the problems I've sketched, I'm not saying we should abandon deep learning. What I'm saying is we need to reconceptualize it. Not as a universal solvent, but simply as one tool among many. And then I kind of gilded the lily and went on for a while. It's a power screwdriver in a world in which we also need hammers, wrenches, and pliers, not to mention chisels, drills, voltmeters, logic probes, and oscilloscopes. So it's great that we have deep learning, but if we really want to get to intelligence, we're going to need some more tools. Whoops. Second thing I would say is there's no substitute for common sense, having knowledge about how the world works. So I have a review also with Ernie Davis in the Communications of ACM of common sense reasoning. The brilliant cover they made was a robot cutting down the wrong end of a tree limb. You don't want to learn this with supervised learning. You have 100,000 robots fall off 100,000 trees, and you gradually increase your neural network weights, and still it stops happening. You want this to happen at most 0 times, right? Because you want to be able to reason about what a tree limb is, what a chainsaw is, and so forth. Here's another example. This is called a yarn feeder. I'm guessing very few of you actually know what a yarn feeder is, but as soon as I tell you, you can look at it, you can say, okay, I hold the ball of yarn, got a little aperture, and a little bit of yarn comes through, right? Now you can recognize another one, even based on a sample of one, not 10 million like you might have in a neural network, and even if it's pixel for pixel different, and in fact but ugly. So this is also a yarn feeder. It looks completely different, but you can immediately recognize that it does the same function. That's what common sense is about. Common sense is also about not having your robot drive itself into a puddle or a pool. And my favorite example of what the lack of common sense costs us in domestic robots, well, it's my favorite example because it's the only domestic robot that anybody has, is the Roomba, and it can't tell the difference between Nutella and dog poo. And so you get this, not occasionally, but a lot. There's actually a word for it, which is the yes, I can never say it, poopocalypse. This is what happens when your Roomba runs into a pile of dog poo. So this is a complete, utter lack of common sense. It's also a sign of a sleepy crowd. I don't know what to do about that. Here's a more serious example. Teslas have been running into fire trucks with regularity. I think it happened 3 times last year on the highway, and there were a couple times when Teslas ran into other stopped emergency vehicles. This is a lack of common sense. Don't run into something that isn't moving on the road, even if it's the kind of thing you expect to be moving. The third point I want to make is that learning isn't just about big data and number crunching, which is what deep learning is about. It's also about learning through exploration, problem solving, having an understanding about how the world works. So here's my daughter about a year ago. We're sitting in a cafe, and she notices that this chair has enough space for her to put her legs through. And so she decides, this is actually a reenactment. It's the second time she did it, because I didn't have my camera out the first time, to my regret. And so she's like, and she didn't verbalize any of this, but she's trying to figure out how to get through the chair. She wanted to climb through the chair. Again, she didn't do this based on a lot of data. She had never seen me do it. She'd never seen the old television program Dukes of Hazzard where they climb in through the window. So she wasn't copying anything. She had set a goal for herself in order to understand how the world worked, how chairs work, how her own body works. And she tries to get through, and she doesn't quite make it. She actually gets stuck, and then she does problem solving and wiggles. Her arm is stuck, and she wiggles, and she figures her out how to get through. This is how human beings solve problems. It's very different from the paradigm we have now of I will label a lot of examples and get a statistical approximation. And we should be thinking really deeply about what it is that my daughter can do that our average AI system can't, or that anybody's daughter can do. The fourth observation I want to make before I stop is that common sense probably starts with an innate, built-in understanding of time, space, and object. And since I don't have a lot of time, I'll refer you to Liz Spelke's work on this, who I think is one of the great developmental psychologists of our time. She argues if you're born knowing what an object is, what space is, what time is, then you can go out and learn about the rest. But if you're born as a blank slate, which is basically the approach that people are taking in the big data approaches of the day, then you're in trouble. Can we turn the volume down a little bit? This is a baby ibex. Like, people never want to believe that humans have anything innate. There are always arguments about that and political arguments. But here's a baby ibex. It's like a few days or a few hours old, climbing around on a cliff. There is obviously something innate in this creature. If it did not have the right innate mechanisms, it would not last very long. And by comparison, in full disclosure or whatever, here's a robot. This is where we are with its innate set of abilities. All right, so to sum up, in the event, let's stop worrying about robots. Let's worry about how dumb AI is and not whether they take over the world. In the event of a robot attack, you can close the door, or if things get really rough, you can lock it. There's no robot out there with a key that can open a door. You can hide behind a bus or dress like a bus. They'll be confused and think you are a bus. Keep a pack of psychedelic stickers handy. There's a lot you can do if you're worried about the robots. And more seriously, deep learning is a better ladder, but just because we have a better ladder doesn't necessarily mean that we're 2 steps away from getting to the moon. And if we want to build machines that are as smart as people, we should start by studying small people. Thank you very much.
Thank you. Thank you, Gary. Well, having burst the bubble of the majority of the room.
Sorry.
I mean, the talk was fascinating, and one of the things I was thinking was that you talked a lot about common sense and intuition. And I guess my question was, do you think, it's even possible to create systems that have the sort of innate intuition and common sense, that we have that kind of a priori knowledge that you spoke about? And also, should that even be an objective?
I think it is possible. I know that you share my interest in philosophy, and I could tell that in the question even if I didn't already know. So I think it goes back to Kant and the critique of pure reason and the arguments that he made that we have a built-in spatiotemporal manifold. Mm-hmm. I think we can do this. We do this in limited domains for like GPS systems. GPS systems have a lot of built-in representations about how to expect the world to operate, how to do the trigonometry on the satellites and so forth. I think it's more of a will problem than a technical problem. I think there's a real challenge. The kinds of models that we have right now are not really, the ones that are popular aren't compatible with innate knowledge. I don't know that you can stuff this stuff into a deep network. But there are other systems like Bayesian approaches and so forth where it's not that hard to build in at least some of this kind of knowledge, prior constraints on how some things operate. We know a little bit about how to do this. I don't think we know enough about it. I think the other thing I would say is biology does it all the time. So, if evolution can do it with an ibex, then, if we sit ourselves down and think about the right objective function, to use the language of deep learning, what it is that we're trying to do, I think we can make progress. I think the problem is right now the field is so obsessed with what seems to be so easy that we're stuck in what people would call a local minimum. Right now, I can just add a little bit more data and look, I can play Go, and it's super exciting to win at Go, which seemed to be hard and all this kind of stuff. But we need a different kind of research program that's really more about looking at how humans solve problems or other animals solve problems and trying to get some clues from there. I don't think it's impossible. I think it's a change in direction.
Okay, so throwing down the gauntlet then.
I am throwing down the gauntlet. That is correct.
Okay, I'm going to throw it out to questions. We've got a couple of roving mics. So we'll go here.
So, if you ask that question about the professor or the mother,
yeah,
in Haiti, with a Haitian, you might get a different result. Or move 37 or 39 in the Go game. It baffled all the human experts, but it turned out to be the move that
it's a very interesting move.
Won the game for Google's DeepMind and Race It All Lost. So, and then, humans are doing massive parallel processing using chemistry. But once you have quantum computers and deep learning, or maybe meta deep learning or something else, you could have AGI.
Well, I mean, my talk is really about why it has to be something else. So you laid out two options. One is we can get more and more computation, more and more compute, and maybe we can use the existing techniques. And what I'm trying to argue is the existing techniques, even in principle, are really only aimed at one facet of the problem, which is perception. They're not particularly good at, for example, chains of reasoning. So you could plot progress over time on Go, and you would see that there's exponential growth. You could plot progress over time on reading, and you'll see there's really not that much. There's a task I didn't have enough time to go into called Squad, where you have to highlight words in a sentence. We've made a lot of progress on that. On chains of reasoning, we really haven't made any progress at all. I'm going to take another question. I know you want follow-ups, but there's also a lot of people raising hands.
I think you made a convincing case that the AI will not mimic the human mind anytime soon. But the question that I'm thinking of is between the input and the output, you are not saying that the AI is being illogical. So the question then is, do you think there's only one type of logic? The AI may have a different concept of logic, and in its subset of the universe it inhabits, moving 3 pixels up is not part of its universe.
Yeah. That's a good question. It's actually a deep question. So the AI in general is not doing something that's sort of mathematically ill-formed, but is doing something different from people. There's actually two questions in what you ask. One implicit question is, does AI have to be exactly like people? And I'd say the answer is no. But could AI do some things better by imitating people? I'd say the answer is yes. So I'll give you a simple example if you know a little bit about computers and binary numbers. So if you teach a neural network of the traditional form, something called the identity function, f of x equals x, the input is the same as the output, on binary numbers, and you restrict yourself to even numbers, and now it will learn all of that. It'll learn that the input corresponding to 1110 is 1110. And now you give it an odd number, and the system will fail. This is work I did in the 1990s, late 90s, that I think presages a lot of what's going on right now. So it will fail to go to odd numbers. You train it on all the even numbers, and it will fail to go to odd numbers. What it's doing is mathematically well formed. It's basically saying, what is the conditional probability that the rightmost bit, the one that makes it an odd number, is going to be a 1 based on the training sample that I've seen? And the answer is 0, And so that's the answer that it basically uses to construct its overall answer. So it says that the identity function for 1111 is 1110, which is absurd to a person. And what that tells us is that the logic, so to speak, that the machine is following is very different from the one the person is following. What the person is looking for is a rule that holds for all possibilities in some class of things. And a lot of the debate, at least used to be, when I was working with Steve Pinker, who was my mentor, a lot of debate used to be about whether humans have access to rules anywhere in their brains. And I think the data has overwhelmingly shown that the answer is yes, but the neural networks that are popular today are trying to get rid of those rules. They don't want to have anything that explicitly says a number, an integer, or a copying function. Now, there's a little bit of work in the last year. People are realizing they need to deal with this. So there have been a couple of papers from DeepMind that have directly followed up the critique that I had a long time ago. So people are starting to think about a new class of models that look a little bit more like computers. They have operations that you can apply to variables, like you'd have in a computer programming language or a microprocessor, that do a different kind of logic. And I think that that's what we need. We have time for one or two more?
Unfortunately not. We are out of time, but thank you very much. Guys, give it up for Professor Gary Marcus.